In this video, we're going to go through some confidence interval problems, like the ones on your homework. There are three types of confidence interval situations that we're dealing with in our class. There's a confidence interval for a population mean when the population standard deviation is known. There's a confidence interval for a population proportion, and then there's a confidence interval for population mean when the population standard deviation is unknown. Your homework has one problem for each type of situation, and in this video, we'll go through one problem for each type of situation. This first problem is a confidence interval for a population mean when the population standard deviation is known. In this problem, the population standard deviation is known and it's provided. We know that it's 12.6. In this problem, a person wants to know what the mean age of a population is. The mean age of the population is unknown, and someone wants to know what it equals. This person takes a random sample of 35 people from the population, records their ages, and gets this data set right here. These are the 35 ages of the sample. Part A of this problem says, what does the sample mean equal? To get the sample mean, you just have to add the 35 ages and divide the total by 35. If you do that, you would get 19. Part B says, is the sampling distribution at least roughly normal? Basically, this part is asking, can a margin of error be calculated? And if you're calculating a margin of error for a sample mean, this is the rule that has to be met, or this is the requirement that has to be met. The population has to be normal, or the sample size has to be at least 30. Like I said, if a sample mean is being calculated and you're calculating a margin of error, this is the rule that you have to check off. You have to check off one or the other. The population isn't normal, it has a skewed shape right here, but the sample size is 30 or larger. The sample size is 35. Since this checks off, we can go ahead and calculate the margin of error. We just have to check off one or the other. This is the formula to calculate a margin of error when for a sample mean when the population standard deviation is known. You have z times the population standard deviation sigma over the square root of n. We just have to plug in these three numbers. To get this z-score, you have to go to the margin of error table that I gave you. It's just a small table with two columns. You go to the 95% row, and you'll find out that the z-score is 1.96. This gets plugged in right here. The population standard deviation sigma is provided in the question. It's 12.6. The sample size is also provided in the question. It's 35. So we just plug in these three numbers. We find the square root of our sample size. We divide, and we multiply. The 95% margin of error comes out to 0.53. Part D says create a 95% confidence interval. To get a 95% confidence interval, you take your sample statistic, which we calculated in Part A, and you add and subtract the 95% margin of error. So we're going to take our sample mean of 19 and add and subtract our 95% margin of error, which came out to 0.53. 19 minus 0.53 is 18.47. 19 plus 0.53 is 19.53. These two numbers are the endpoints of our confidence interval. Now we can reach our conclusion. Our conclusion is we're 95% confident that the mean age of the population is between the two endpoints of our confidence interval. We're 95% confident because we calculated a 95% confidence interval. That's where the confidence level comes from. Let's move on to the next problem. In this problem, we're going to be calculating a confidence interval for a population proportion. In this problem, a person wants to know the proportion of homeowners in a population. What the person does is the person takes a random sample of 35 people and asks each person, do you own a home? This person gets 35 yes-no answers, and this is the person's data set. The person's data is showing 20 yeses and 15 nos. Now we can go to part A. Part A says, what does the sample proportion equal? This is asking what proportion of the sample owns a home. To get this answer, we just divide the 20 homeowners in the sample by the total sample size of 35. 20 divided by 35 is 0.57. This is our sample proportion, or our p hat. P hat is sample proportion. Part B says, is the sampling distribution at least roughly normal? This is basically asking, can a margin of error be calculated? If you're calculating the sample proportion and you're calculating a margin of error to go along with it, this is the requirement that has to be met. In the last time we calculated a margin of error for proportion, it was n times p and n times 1 minus p. It wasn't p hat. But in this question, the population proportion is unknown. It's not provided, which means we have to substitute the population proportion with the next best thing. The next best thing is our sample proportion, p hat. So we put p hat in its place. So n times p hat and n times 1 minus p hat both have to be 10 or larger. N is the sample size. And like I said, p hat is our sample proportion. 35, our sample size, times 0.57 is this number. 35, which is our sample size, times 0.43, or 1 minus 0.57, comes out to this number. They're both 10 or larger, so they both check off. So we can go ahead and calculate the margin of error. In this situation, when you're calculating a margin of error for proportion, they both have to check off. It can't just be one or the other. So this is the formula for the margin of error of a proportion. Just like before, we go to the table and we get the z of 1.96. Over here, we have to plug in our p hat from part A of the question. It's 0.57. And plug in our sample size, which is 35. When we do all of this work, we get an answer of 0.16. That's our 95% margin of error. Next, we create a 95% confidence interval by taking our sample statistic, which in this case is the sample proportion, and adding and subtracting our margin of error. So our sample proportion was 0.57 in part A. We're going to take the 0.57 and add and subtract 0.16, the margin of error. When we subtract, we get 0.41. When we add, we get 0.73. These are the two endpoints of our confidence interval. And our conclusion is we're 95% confident that the proportion of homeowners is in the population is between 0.41 and 0.73. Remember that in this problem, we're interested in the proportion of homeowners in the population. That's the unknown number that we're interested in. And now we're 95% confident that that unknown number is between these two numbers right here. This is the third type of confidence interval problem. It's a confidence interval for a mean, and the population standard deviation is unknown. It's unknown, that's why it's a question mark. We're taking a random sample of 5 people from the population, and we're recording their 5 ages. Just like before, part A says, what's the sample mean? To get the sample mean, we add the 5 ages right here and divide the total by 5. It comes out to 19. Part B is asking, is the sampling distribution at least roughly normal? Which basically means, can we calculate a margin of error? The population is normal. We can see that right here. So we've met our requirement. We have to check off one or the other. Next, we calculate a 95% margin of error. Since the population standard deviation is unknown, we're going to a different table. We're going to a t-table. When you go to the t-table, the row is actually 1 less than your sample size. If your sample size is 5, you go to row 4. That's because the rows are actually labeled after n minus 1. They're labeled with the n minus 1 that goes along with the sample standard deviation. So we have a sample size of 5. We go to row 4. Our column is 95% because we want the 95% margin of error. In the t-table, the confidence levels are labeled at the bottom of the table. So we have to go to the bottom of the table and look for 95%, and then that's our column. And it looks like our number is 2.776. That's our t. Next, we have to get the sample standard deviation. Since we don't know the population standard deviation, we have to calculate the standard deviation of our sample and use it as a replacement. So we take the 5 ages, the 5 data values, we subtract all of them, we subtract each one by the mean of 19. We get deviations. We square each deviation. In other words, we multiply each deviation by itself. We add up the squared deviations, and we divide by n minus 1. Remember, when you calculate a sample standard deviation, you divide by 1 less than the sample size. Our sample size is 5, so we divide by 4. And 2 divided by 4 is 0.5. Actually, the answer is the variance. Sorry, the variance is actually 0.5. This is our n minus 1 right here. The variance is the mean of the squared deviations. Next, we get the square root of the variance, and that's our standard deviation. So our standard deviation is 0.707. So now we have all the numbers we need to plug in to get the margin of error. Our t from the t-table is this number. Our sample standard deviation s is this number, and our sample size was 5. If we do all of the work, we get 1.24. That's a 95% margin of error. Now we're ready to calculate a 95% confidence interval. We take our sample mean from part A, and we add and subtract our 95% margin of error. When we subtract, we get this number. When we add, we get this number. And now we're ready to make a conclusion. We're 95% confident that the mean age of the population is between these two numbers. In this situation, the unknown number that we care about is the mean age of the population. That's what we're trying to estimate. And now we're 95% confident that that number is between these two numbers.